Assalamualaikum to our lecturer, Dr. Hani. So today, we from Group 2 will present our report on our last fieldwork.
The first location that we go during the fieldwork of geomorphology is located at Jalan Kampung Lombak behind the University Malaysia Sabah. That is around 2.8 km from UMS. This location is easily accessible and suitable for field observation. The site is a cut slope where excavation has exposed both soil and bedrock layer. From the image, we can see that the slope is quite steep, has very little vegetation, and its height is estimated to be around 4.5 to 5 meters. Because the slope is exposed, rainfall and surface runoff play a major role in shaping the area. Physical weathering is clearly visible through the fracture and joint in the rock, which allow the rainwater to enter and gradually break the rock into the smaller fragments. On the soil covered parts of the slope, gully erosion can be observed. This is caused by the concentrated surface runoff during the heavy rainfall, forming the narrow and deep channel. Chemical weathering is also present, especially oxidation, which is indicated by the reddish brown and yellowish color on the rock surface. This process weakens the rock internally. In addition, biological weathering occurs when plant roots grow into existing cracks, widening them and increasing the moisture retention. Overall, the interaction of the physical, chemical, and biological weathering together with the erosion and minor mass movement lead to gradual slope that's weakening at the Jalan Kampung Lumbak behind UMS.
At the second site on the first day of the trip, we go to the Sungai Tamparu. This location located near the town of Tambarani within the Tuaran district and consists of the curve of Mendo deposition of Simba and the flow of water current. The geomorphological features that we found here is erosion, deposition, and Mendo curve. For the erosion, we have the biological erosion by the river, include three phases, which is mechanical, intermediate, and sedimentary. As for this deposition, we can see the deposition of Simba near the river bank. As for the meander, which is the curve, it is have a low water current near the inner cave, meanwhile at the outer cave it have the high water current.
During our field trip to the Inanam Taipan terrain, we observed sandstone faults showing two distinct colors, which are green-grayish and reddish-brown. The green-gray is due to chloride, which oxidizes under heat to produce reddish hues from iron minerals like hematite. We also identified folded like anticlines and synclines that shows the cores showing reddish colors from thermal effect and weathering, while the hinges remain greenish. Joints and fractures in the syncline are caused by compression, uplift, and water runoff, which also promote erosion. Additionally, the upper terrain shows signs of human destruction, with linear marks and ongoing construction affecting the landscape.
For the second day, the first site that we go is the Kappa Quarry. This quarry located at the Jalan Tamparoni Terengganu within the Tuaran district Terengganu. This location consists of intrusive igneous rocks. The geomorphological that we found here is texture of rocks, which is the rock have the porphyritic because of the distinct crystal embedded in a much finer grain matrix. The second is the types of rocks. The types of rock is intermediate rocks because it composed mostly of hornblende and intermediate plagioclase feldspar. And lastly is the name of the rocks. The name of the rocks is granodiorite. It is because of the presence of quartz and the hornblende.
For the second location on the day 2, it's located at Jalan Kampung Marakau Inanam. From this picture, we can observe from this location we can observe that the limestone bed inclined and clearly exposed due to the road cutting. The height is approximately 6 meters. That estimates using a human scale reference. The visible joint fracture vegetation growth along the crack and loose debris at the base indicate that the weathering and erosion are actively occurring at this site. Moving on for the first picture, this image shows a specimen of limestone with a coin used for the scale. The limestone has a fine-grained texture and well-defined bedding planes. A distinct orange band can be seen in the middle of the specimen, which is identified as a quartz vein. This quartz is believed to have formed when silica-rich fluid filled the fracture or the bedding planes within the limestone. The surrounding gray limestone represent pressure carbonate material, highlighting the mineral variation within the rock. Next, the weathered limestone fragment from the same locality. The rock surface appear rock and uneven, indicating the stronger chemical weathering. A gray quartz band is still clearly visible and remains more intact compared to the surrounding limestone. This shows that quartz is more resistant to weathering, while the limestone around it has undergone chemical alteration.
So next is Road to Ranau Sport Complex. So as we can observe here is the rock type is ultramafic igneous rock. So for the rock characteristic is the rock appears dark in the color due to its high iron and magnesium content that show a massive structure with no visible bedding, indicating a non-sedimentary origin. Second is the process that can be observed is fracture and joints observed on the exposed rock surface, like as we can see on the picture above, is because it indicate the physical weathering processes occur after the rock was exposed during to road construction. And last is about the geomorphological link. So this site demonstrate how exogenic processes, particularly weathering, act on ultramafic igneous rock and contribute to soil formation and surface landscape development.
Lastly, during our visit to Kampung Bong Putranau, we studied terrain composed of penasol gravel, a sedimentary deposit from ancient glacial and mudflow events originating from Mount Kinabalu. The site consists of sandstone, sublithoranite, and subacose, occasionally containing red quartz veins, which indicate minor thermal alteration. On the slopes, we observe talus and scree deposits formed by physical weathering processes such as rock breaking and gravity-driven transport. Many boulders exhibited glazing gangrene caused by oxidation of iron minerals and onion skin weathering, resulting from repeated thermal expansion and contraction. Evidence of boulder unloading and mass wasting was also present, contributing to the smooth, sandy deposits downslope. Importantly, the nearby retaining wall shows cracks and tilting due to a rotational landslide, which created void spaces beneath the wall, with vegetation growth further highlighting the slope instability. Our observations collectively demonstrate the interplay of sedimentary deposition, physical and chemical weathering, and also erosion-driven mass movement in shaping the landscape.